So hello everybody, myself Vinit Patil from IIT Patna, B.Tech. So I will be providing the solution of this problem. So the problem is from CAT 2025 slot 2 quant. The problem is as follows. The sum of digits of number 625 power 65 into 128 power 36 is. So firstly we have to simplify the two terms. So 625 can be written as 5 power 4. So 5 power 4 whole power 65 into 128 can be written as 2 power 7. So 2 power 7 whole power 36. So a power b power whole power c can be written as a power b into c. So further we simplify it to write it as 5 power 4 into 65 into 2 power 7 into 36. So this gives us 5 power 260 times 2 power 252. So now we can multiply 5 power 252 into 2 power 252. It will become 10 power 252, and the remaining 5 power 8 can be used to calculate the sum of digits. So here we go. So the sum of digits for this will be 0, as 252 zeros will be followed by this number. So 5 power 8 is 39625 into 10 power 252. So sum of digits by this is 0. So we can calculate sum of all these digits and it will be the final answer. So it is 12, 18, 20, 25. So 25 will be the final answer for this problem. So our next problem is from CAT 2025 slot 1 quant. The problem is as follows. The number of distinct integers n for which log of n square minus 7n plus 11 to the base 1 by 4 should be greater than 0. So firstly we will transform this log to the right hand side to simplify this equation. So the equation becomes n square minus 7n plus 11 less than 1 by 4 power 0. 1 by 4 power 0. So here one important point is that the inequality sign changes because the base of logarithm is less than 1. Here the base is 1 by 4, so the inequality sign is changed. So as everybody know, anything power 0 is 1. So we can further simplify the equation and write. So it becomes n square minus 7n plus 11 less than 1. So it can be written as n square minus 7n plus 10 less than 0. So for this equation it is possible to do factorization. So upon factorization we will get n minus 5 times n minus 2 less than 0. So for this inequality, the solution to exist, one term must be positive and the other term must be negative. So the solution lies in between 2 and 5. So what we have to do? So we want number of distinct integers n. So distinct integers n existing between this range would be n equal to 3 and 4. So the answer will be 2. So the next problem is from CAT 2025 slot 1 from quant. So the question is as follows. If a minus 6b plus 6c equals to 4 and 6a plus 3b minus 3c equals to 50, where a, b and c are real numbers, the value of 2a plus 3b minus 3c is. So upon observation, one can say that these two terms are common in between. So firstly, we'll take this equation and transform a to the right hand side. So 3b plus 3b minus 3c becomes 50 minus 6a. So for required term, we should add 2a on both sides. So 2a plus 3b minus 3c equals to 50 minus 4a. Okay. So from these two equations, one by observing carefully, we can say that if we multiply this equation by 2 and add both, the b and c term will get cancelled and we'll automatically get the value of a. So we will do the same process here. So firstly, a minus 6b plus 6c equals to 4 and 2 times multiplied by this equation. So it will 12a plus 6b minus 6c equals to 100. So we have to add this equation. So 13a, both b and c terms get cancelled, equals to 104. So the value of a becomes 104 divided by 13, which is equal to 8. So required required value should be 50 minus 4a. So we'll substitute a value here and we will get the answer. So 50 minus 4 times of 8, which is equal to 50 minus 32, which equals to 18. So our correct option is C, 18. So this is final problem. The problem is from CAT 2025 slot 1 from quant section. The question is as follows. A container holds 200 liters of a solution of acid and water having 30% acid by volume. Atul replaces 20% of this solution with water, then replaces 10% of resulting solution with acid, and finally replaces 15% of the solution thus obtained with water. The percentage of acid by volume in the final solution obtained after these three replacement is nearest to. So initially 200 liters of solution is out present, of which 30% is acid. So acid is 60 liters and water is 140 liters. So here I have written initially acid is 60 liters and water is 140 liters. So after that Atul replaces 20% of this solution with water. So 20% of acid is removed. So 12 liters is removed and 28 liters is removed from water. So these are the remaining quantities of acid and water. So after that it is replaced with 20% of water content. So 40 liters of water will be added into it. So the final ratios after first replacement are 48 liters of acid and 152 liters of water. So after careful observation, one can say that we have only removed 20% of the acid and just added it into the water content. So means we have added just same amount into the water. So we use this trick for the next parts of replacement so that we can save our time. So nextly, Atul replaces 10% of resulting solution with acid. So 10% of resulting solution is replaced with acid. So basically we will reduce 10% of water from here and add it here. So the total acid content becomes 63.2 liters after second replacement, and water content becomes 136.8 liters. So final and third replacement is Atul replaces 15% of the solution obtained with water. So Atul reduces 15% of the solution, acid solution, and directly adds same amount into water, so which is 9.48 liters. So after the third replacement, the total amount is of acid is 53.72 liters and remaining is water. So the required solution is the percentage of acid by volume in the final solution obtained after these three replacement is nearest to. So acid content is 53.72 liters by total content is 200 liters into 100 gives us percentage content of acid. So it is equal to 26.86%. So it is nearest 27. So our final answer is 27.